In this short video clip, we're going to look at shaft encoding using binary encoders and grey encoders. To begin with, we're looking at a binary encoder. This is a 3-bit binary shaft encoder. What that means is, as the shaft rotates, sensors that will be connected to this disk will record a binary number that will represent the position of the shaft. Because there are 3 bits, there are 8 sectors on this shaft encoder. That means that these sensors can detect the position of the shaft to within 45 degrees of any of the original position. Let's now look at this shaft encoder face head on. So we'll rotate it, and now we want to record the position or the values of these sensors as this shaft makes 1 revolution. In its current position, the sensors are reading 000, and we read this binary number with the most significant bit on the inside and the least significant bit. Most significant bit on the inside, the least significant bit position is treated as the outside of this number. As the shaft begins to rotate, nothing happens to the sensors until we reach the boundary between the first sector and the second sector. This would indicate that the shaft had rotated. As we cross this boundary, this will indicate that the shaft is moving from between 0 and 45 degrees to between 45 degrees and 90 degrees. And as the as the least significant bit sensor crosses the boundary, it changes from 0 to 1. So our binary number 001, it now represents the fact that we've moved from, as I said, from the first sector or the 0th sector into the first sector position. When we come to the boundary between the first sector and the second sector, we have a slight problem, and that is that 2 sensors would change as we cross this boundary. Now, these sensors don't necessarily change simultaneously, as you'll see in this demonstration. The middle sensor changes just a microsecond or 2, millisecond or 2 before the outer sensor changes. And this means that the shaft encoder is recording a binary number of 3 when it should in fact be recording a binary number of 2, because we're now moving into the second sector position. Now, if that code was picked up by our electronic sensor, we might believe that the shaft is in a slightly different position, temporarily in a different position to where it really is. As the shaft continues to rotate and we cross the next boundary between these 2 sectors, you'll see that this time we don't have a problem, because only one of the sensors changes, and that means that we're now in sector 3 and we're getting the correct code from our shaft encoder. But when we come to the next sector, we have another problem, because we've got all 3 sensors, all 3 of these sensors are going to change, and we don't know in what order they might change. So at the moment, the inside sensor, or the most significant sensor, has changed first. It's gone from a 0 to a 1, whilst the other 2 sensors have remained at 1. So this code that's being generated is actually the code for sector number 7, whereas we're actually going to move into sector number 4. So then when the shaft turns just a fraction of a degree further, the outside sensor changes, and we're now recording a number on our binary code. Is now generating a number 6, indicating that we're in sector 6, whereas in fact again we're moving into sector 4. And it's only when we finally get the 3 sensors well into the 4th sector that we get the correct code generated for that sector. So you can see that using binary encoding to record the position of the shaft is not a very good idea, because certain combinations, as we rotate around, will give erroneous readings on our sensor. And that is caused by the fact that, especially as we take this last position where we're moving from the 7th sector back into the 1st sector position, you can see, because all 3 sensors are going to change their values as we cross this boundary, and we don't know in which order they will change, we can get a whole range of spurious readings on our encoder before we reach the correct one. Now, to get around this problem, we can use a grey code encoder. With a grey code encoder, we don't, the pattern of recorded on the different segments of the encoding disk doesn't follow the usual binary number system pattern. It follows a different pattern, and the pattern is called a grey code. The grey code is deliberately arranged so that when you move from one sector to the next, only one bit changes at a time. And this, so let's quickly look at it. So we're rotating from the 0th sector to the 1st sector, and as you can see, only one of the sensors changes. It's the least significant bit position sensor. So we now get our code. The code 001 now represents sector 1. Now you might say to yourself, well, that was the same code as we got with the binary encoder, which is true. But that's not always going to be the case, as you'll soon see. As we move from sector 1 to sector 2, the middle sensor changes, and the outer and the inner sensors do not change. So we don't get any spurious codes generated, but at the same time, the code that we do get to represent this sector is not the usual 010 that we would get with the binary encoder, but is in fact 011. There's no problem with this, because of course our detector that's sensing these codes can have a lookup table or whatever to turn these codes into angles. So there's no problem with that. It's just a code to represent that sector. As we move into the 3rd sector, you'll see that the innermost and the middle sensors again don't change. It's only the outermost sensor changes. So we get a grey code of 010, and then as we move into the 4th sector, we get again only one sensor changing, and we get a grey code of 110. So by using a grey encoded disk attached to our shaft, we are able to record the position of the shaft to within the appropriate number of degrees, and that's of course dependent on the number of bits that we use for our grey code. This is just a 3-bit grey code encoder, so therefore we can only represent angles between 45 degree changes in the shaft rotation. But if we wanted more accuracy to our shaft encoding, we would use a larger grey code. Okay. But the main thing to notice is that the codes, only one of the sensors changes as we move from one sector to the next, and therefore we overcome this problem that we get with the binary encoded disks.